The first speaker is Mr. Ernani Judice, CEO at Geociclo Biotecnologia. Ernani is responsible for investments development of Olavo Monteiro de Carvalho, a widely known Brazilian entrepreneur. He is an experienced entrepreneur focused in venture capital investment structuring, implementation, and operation. Being executive director of ventures, he passed through some sectors like industrial, health, urban residue treatment, selective collection and urban cleaning operations, hospital cleaning and sanitization. Mr. Judice is graduate in business administration. His presentation is about organomineral fertilizer, the solution to increase agricultural performance with competitive costs and sustainability. Please, Mr. Ernani.
Thank you, Gustavo. My name is Ernani Judice. I'm the CEO of Geociclo Biotechnology, a Brazilian company specialized in biotechnology to produce fertilizers. I'm going to talk about organic mineral fertilizer and a solution that is a fertilizer that is sustainable, efficient, and with very competitive costs. So in the beginning, I'd like to show a video that gives an overview of the concept of the business model, and then we go to the presentation, please. Okay, I'm sorry, the video is in Portuguese, the presentation will be in English, so I think it's a good balance. So it's just an overview of our concept. So I'll start the presentation. All right, so I'm here to present you a fertilizer that is, like I said, efficient, very efficient, sustainable, but most importantly, with viable costs, with competitive price. This is a scenario of plenty of opportunities, like I'm going to present. First of all, I'm going to show you some important data. The population of the world is going to grow 23% in the next 20 years, but the residual generation will grow about 75%, because this population is growing in developing countries, so the population is getting more developed, so we need to produce more food, and we have these huge volumes of residues being generated, and the world just not absorb it. We need technology, we need to develop technologies to treat it and to deploy it correctly, all right? Another challenge, another opportunity, so there's an opportunity there, we have to produce more, we have residues. At the same time, talking specifically about Brazil, we have, like we've heard in the morning, that we have agricultural land, but our soil is poor, very low fertility soils. Like you saw in the video, the deployment of fertilizers, in Brazil, comparing with other countries, so we have to deploy much more because the losses are huge. So there's a huge opportunity here at the same time that it's a challenge. So this is a picture of the traditional fertilizer used in Brazil and in many parts of the world, the traditional blend of NPK, the granular blend of NPK. It brought many gains to the producers, to the farmers. For years it's been used and brought gains. But for the current technology-driven, efficiency-driven agriculture of the world, of Brazil, for example, it's inefficient. It's not bringing results anymore. We saw some products, some chemical products, some coatings, some products that are being developed and introduced to the market. Nothing very, very different. So what we're trying to show here is a specific product, a very different product in terms of its physical characteristics and so on. I'm going to explain to you, but that's when innovation steps up. When there's a challenge, an efficient product, like I said, that's when innovation steps up. That's our product. We combine the organic matter, stabilized organic matter from sources of residues, and with the NPK, with the nutrients, with the macro and micronutrients, and we produce this pelletized fertilizer. In the end of the day, this is not a simple, regular pelletized fertilizer. We had to develop the whole process, the engineering process, the equipments, in order to have a product that has some physical characteristics similar to the NPK. So hardness, density, humidity, it's very similar to the NPK, so to the granular blends of NPK in terms of physical characteristics. So in the end of the day, the farmer, the producer, he can use the same equipment with no costs added. So he can just deploy our product without changing his structure, okay? So this product, as you can see there, you have the NPK with the organic matter all glued together, all stuck together, pelletized. And this organic matter works as a capsule. And when it goes to the soil, this organic matter is slowly degraded by the microorganisms, and it slowly releases the nutrients. We have an organic polymer within this pellet. It's not around it, it's not a coating, it is within it, gluing, stuck in the NPK with the organic matter. So it really slowly releases the nutrients. That's the biggest, the most important thing. It doesn't delay the release, it really slows the release. Of course, any innovation, any product that is new, it's a pioneer. You have to run many tests, and the scientific development of it is very important. We've run many tests, always with universities and technical institutions alongside running the tests. So we brought up some very consistent gains, such as corn, such as soybean and sugarcane, 22%, 20% there with sugarcane, and so on. We have many tests, many results, different crops, different areas, different volumes, different formulations, and so on. This is the process, okay? So we can use a variety of residues. But mainly, we can use poultry litter, residues from forests, from soybean, from corn, industrial residues, and mainly what we're using right now is the residue from sugarcane industry. Like our friend from CTC said before, we have this huge sugarcane industry in Brazil. We have to double our production in the next 10 years. And these sugarcane mills are generating huge volumes of residues, especially the filter cake that is not used to generate energy. They are just deploying back to the soil with very high costs. So what we do is we take these organic residues from various sources, we bring it to our labs, as I'm going to show you later on. We developed a specific technology to accelerate the composting process of these residues. We have some other processes, but mainly nowadays we're using the composting process because this is the one that get rid of the contamination with better results. So we have this stabilized organic matter. Then we bring we bring to our industrial plants. We add the minerals. We produce the pelletized organic mineral fertilizer. We deploy in the soil. The crops just get developed, and we close the cycle. It goes back again, and so on. That's the cycle, okay? So especially with the sugarcane mills, we can receive the residual, produce the fertilizer, and sell it back to them, reducing their costs of fertilization, okay? So in order to develop this technology, this product, we had to invest a lot in research and development, engineering, and industrial sites. All of this we had to develop. There's no standardized plant or equipment in the world, so we had to develop it all. First of all, we have our labs. We have microbiology labs, we have physical chemical labs, agronomy labs. We have 20 people working in research and development, PhDs in microbiology, chemical engineering, agronomy, and so on. You have the physical chemical labs, so we have to take the residue and characterize it, study the residue and develop a specific technology. We use the biotechnology, the microorganisms, the scale-up of biotechnology areas to try composting trials and so on, okay? So this is the first part. You have to develop the technology. So big investments in research and development, and then the engineering process, the equipments, the plants, okay? We couldn't find anything that could suit our technology, so we had to develop it as well. So we developed, for example, a composting machine. You add the biotechnology, but you have to control the process. And we use this specific equipment that we have developed, and we have also developed the structure, the projects, the process of the factory. You can see the industrial site, for example. So this is a picture of one of our sites, of one of the factories. We have one factory running. We're going to be producing 100,000 tons of organic mineral fertilizer until the end of the year, any formulation with very high level of NPK, okay? We are also building 2 other factories for 100,000 each, so in the end of 2014, we're going to have 3 factories, 300,000 tons of production capacity installed. So we're growing fast. The product is very good. The results are great. It's very efficient. And because of its efficiency, it can go to the market with a very competitive cost. You can pay for the same price of the organic mineral, you can pay for organic mineral and have better results in the end of the day. This is, for example, the product of the site. You can see that we need, it's a much more complex site than a regular blending, fertilizer blending site. We need an area to blend the compost, to receive all these different sources of compost, of residues, where we blend it and we introduce the biotechnology. So we need a huge area to do that. Then it goes to the composting area, where we control the process for 15 to 20 days, and it gets stabilized. And then it goes into the factory, into the plant, where we produce the fertilizer, the organic mineral pelletized fertilizer, and then dispatch it. So it's quite a different site. You need the compost blending. You need the composting area. You need to produce the organic matter, and then add the minerals. So that's it. It's just a quick overview. I try to be to do in 10 minutes. I think I've done it. But mainly, I'd like to talk just briefly to end up about innovation. Innovation is a process that requires, first of all, patience. I can tell you that. It requires investment, capital, technical teams. You need talent, you need structure. And it's very important, and we're going to talk about it later, but it's very important to be very careful, with the scientific results of it. We've run many tests. We invested 5 years in research and development before going to the market. So it's very important to bring products that have been tested, have been approved, and to bring it to the market in order to bring innovation to the market without, selling something that you cannot deliver. So that's our goal. I think we've done a pretty good job so far, and hopefully we're going to keep on bringing some very good projects to the market. Thank you.
Thank you, Ernani. Good job.